And now, time for a sample problem. As it reads, how many grams of aluminum oxide form when 67.0 grams of aluminum reacts with excess oxygen? In order to get anywhere in this process, we first need a balanced equation, which means you also need to know those naming rules that you worked oh so hard on back around Thanksgiving. So we have pure aluminum, Al, plus oxygen, which is not just O, it is part of Brinkelhoff. Yeah, I said it, Brinkelhoff. That means that it gets a subscript 2, because any element that's part of Brinkelhoff always travels with a partner. So you will never find O completely by itself floating around in the atmosphere. It's going to be O2. And when you put these two items together, they react and they form aluminum oxide. But naming rules say this is a positive 3 charge, it disco dances down. This is a negative 2 charge for the oxygen, which also disco dances down. Al2O3 is the final result for aluminum oxide. We still aren't done with the balanced equation though. We have the front numbers that I referred to earlier in order to balance. So a quick review, start with the least complicated element, which is the one that shows up the fewest number of times on the left and right, and just pay attention to that one to make it balance. This left side of the arrow has 1 aluminum, the right side of the arrow has 2, so we can simply put a 2 right there. Okay, now move on to the next element. This oxygen comes in pairs because of Brinkelhoff. This oxygen comes in triples. That's kind of annoying. If this is an odd number, and this is even, you will always get evens on the left-hand side, which means we need to turn this into an even number, because it's impossible to get an odd number if you just add up lots of groups of 2. So if we double this, not only does it give us a different number of oxygen, it affects our aluminum that we thought we had finished. So before you go on, fix the aluminum that we were already working on, which means that just gets erased, and now we have 2 times 2 is 4 aluminum, which means 4 aluminums on the left. Back to the aluminum oxide, what did putting a 2 there do to our oxygens? We now have the front number times the subscript gives us 6 oxygens. So over here, we need to also equal 6 oxygens, which means we can simply put a 3. This leaves the final balanced coefficients as 4 aluminums plus 3 oxygens, that's the partnered oxygen, equals 2 aluminum oxide. We're finally ready to get going on this process. So we're still going to be working with the molar roadmap, aka office building, and we're starting with grams. We have 67 of them, and we need to go from grams on the first floor, which is just aluminum, to grams all the way up on the 3rd floor, which is aluminum oxide. Every single one of these molecules is a different floor. So the office of grams for aluminum is the 1st floor, and you can go to moles or molecules or atoms of aluminum. But if you want to get to either pure oxygen or aluminum oxide, you must take the elevator. So let's get this thing started with the chicken scratch method. Straight bar, whatever number they gave you in the problem always goes in the upper left. In this problem, once you get to stoichiometry with more than one floor, you will want to use labels and be very meticulous about it. It's so easy to get confused, and you want to know exactly which office you're in and which hallway you're about to walk down. So if you just put numbers in this process, it's technically possible, but trust me, it's just a lot easier if you take the time to write out the labels. So we're in grams, and we are in the aluminum floor. Now, I'm going to leave the grams office on the aluminum floor and try to walk toward the grams office on the aluminum oxide floor. I can't go straight there, so I have to go down the hallway first to get toward the elevator, which means whichever office you're leaving, those units go on bottom. Whichever office you're going toward, those units go in the numerator. So this password, I hope you remember from last time, it was the molar mass from the periodic table and 1 mole, depending on which one goes on the top or the bottom. So grams gets dropped to the denominator because that's the office we are leaving. Moles goes to the numerator, and we do know that the number in front of moles is always 1. Now, if we look on the periodic table, we see that aluminum is 26.98. Again, you could round it to 27, but I don't recommend it. Just keep as many decimal places as you can. So now we've arrived in the moles office. Now we can get on the elevator. This is a new step, though. We didn't talk about this last time, and I kind of lied. I'm sorry, I don't make a habit of it, but you remember how the number in front of moles is always 1? Yeah, that's not true. If you're writing an elevator, it's going from the moles office on one floor to the moles office on another floor. Those numbers are not necessarily 1. In fact, they come straight from the balanced coefficients. So whichever floor you're on, that's the number for the elevator step. So we have 1 mole, and I did not do that correctly. I should have labeled which floor I was on. We are still on the aluminum floor for both of these. So the office that we are now leaving is moles of aluminum oxide. That goes in the bottom. And we are walking down the hallway of the 3rd floor toward the grams office. So that goes in the numerator. But we have to get past the guard or else he won't be kind, which means we need to know the password. We need the molar mass of aluminum oxide matches with the G for grams. The number in front of moles, if you are in a hallway, is still always 1. If you're in an elevator, it's not, but if you're in a hallway, the number in front of moles is always 1. If you add up on the calculator aluminum times 2 plus oxygen times 3, you should sum to 101.96. From here, check to make sure your units canceled. Because we designed this whole process so that they would, I think we'll be in luck. Moles aluminum oxide, moles aluminum oxide. Moles pure aluminum, moles pure aluminum. Grams of aluminum on the denominator, grams of aluminum in the numerator. Hooray! The only thing we have left in this whole problem for units is grams of aluminum oxide. Good thing that's what the question was originally talking about. That means all we need to do is type it into the calculator for the final number. 67 times, yeah, we're going to skip the 1. 67 times 2 times 101.96 divided by, and this is where it gets kind of tricky, either open a set of parentheses as you're typing this in, and then put 26.98 times 4, close parentheses, enter. That will work. Or you can also start over at the beginning, do 67 times 2 times 101.96 divided by 26.98 divided by 4. I know it's weird to put 2 different division buttons without any parentheses, but on the TI-85s and 84s, it will work. So anything on the denominator gets a division button before it. Anything in the numerator gets a times button. If you like the idea of putting parentheses and then just multiplying everything in the denominator, that's good too. After this whole process gets inputted into the computer, we should land on 126.6. And then we need the label for that, which is the only label that we have left in this whole process. Grams, Al2O3. One final check, do we have the correct number of sig figs? Because the original question only had 3, there's a pretty good chance we want this to round up to 127. And that is the end of stoichiometry. Now, that's not actually the end. Yeah, that's right. It's the end of that sample problem. But there are other routes that we could take inside this office building. For example, if you started at grams on one floor, the question could very feasibly ask you how many molecules of something else are formed. Well, if you start at grams and go to molecules, it's not that big of a difference. You still just walk down the hallway and then take the elevator to the other floor and then walk down the other hallway. You'll get the right answer if you use this process. In fact, you can take more than one route. You could go first floor grams to first floor moles to first floor molecules, and then take the elevator there, because an elevator actually exists to go from molecules up to molecules of a different thing. So in that way, you just need to learn how to walk around to the different offices and floors of the molar roadmap. That takes care of all the unit conversions that you'll need for first year general chemistry. Hooray!
All right.